Right, let's talk about the universe. Not just our planet, not just our solar system, but the whole shebang. We're talking about the observable universe, the bit we can actually see from our little corner of space-time. Think of it as our cosmic neighborhood, except the houses are galaxies, and the streets are, well, mind-bogglingly vast distances. The farther away something is, the longer it takes for its light to reach us. So, when we look at distant galaxies, we're actually seeing them as they were billions of years ago. It's like looking back in time. But here's the kicker. The universe is expanding, which means that some parts are moving away from us faster than the speed of light. And since nothing travels faster than light, the light from those regions will never ever reach us. So, how big is this observable universe anyway? Well, buckle up, because the answer is truly mind-blowing. The observable universe is estimated to be about 93 billion light-years in diameter. Let me put that into perspective for you. 1 light-year is the distance that light travels in a year, which is about 5.88 trillion miles. Now, imagine traveling that distance, not for 1 year, but for 93 billion years. It's enough to make your head spin faster than a pulsar. If the observable universe were shrunk down to the size of Earth, our entire solar system would be smaller than an atom. We have no idea how much more universe is out there beyond what we can see. It could be infinite for all we know. Remember how I said the universe is expanding? No, it's not like your uncle's waistline after a holiday feast. It's expanding in a much grander, more mind-boggling way. Imagine the universe as a giant loaf of raisin bread dough. As the dough rises, the raisins, representing galaxies, all move farther apart from each other. The same thing is happening in the universe, except instead of yeast, we have something called dark energy causing the expansion to accelerate. We don't know what dark energy is exactly, but it's like the universe's way of saying, "Make way, I'm still growing." For one thing, it means that the distances between galaxies are constantly increasing. And secondly, it means that the universe was once much smaller and denser than it is today. According to the Big Bang Theory, the universe was once condensed into a single point, smaller than an atom. Now, let's zoom in a bit and explore some of the fascinating objects within the observable universe, shall we? First up, galaxies. Galaxies are vast collections of stars, gas, dust, and dark matter, all held together by gravity. Think of them as giant cosmic cities, each with their own unique character and charm. There are spiral galaxies like our own Milky Way, elliptical galaxies that look like giant cosmic eggs, and irregular galaxies that seem to have missed the memo on galactic fashion altogether. Our Milky Way is a pretty average-sized galaxy, with about 100 billion stars. But some galaxies, like the behemoth IC 1101, can contain trillions of stars. Section 5. Stellar nurseries, where stars are born. Speaking of stars, those twinkling wonders we see in the night sky are more than just pretty lights. They are giant balls of hot gas, mostly hydrogen and helium, that produce their own light and heat through nuclear fusion. Stars are born in giant clouds of gas and dust called nebulae. Think of them as stellar nurseries, where baby stars are formed from collapsing clouds of interstellar material. As the cloud collapses, it heats up, eventually reaching temperatures high enough to ignite nuclear fusion in its core. And voila, a star is born. Stars come in different sizes, colours and temperatures. Our Sun is a yellow dwarf star, pretty average as far as stars go. But there are also red giants, blue supergiants, and white dwarfs, each with their own unique properties and life cycles. Section 6. The mystery of dark matter. We can't see it, but it's there. Now, let's talk about something a bit more mysterious. Dark matter. Dark matter is a mysterious substance that makes up about 85% of the matter in the universe. The catch? We can't see it directly because it doesn't interact with light or other electromagnetic radiation. So how do we know it's there? We can infer its existence from its gravitational effects on visible matter like stars and galaxies. It's like knowing there's an invisible elephant in the room because you can see the furniture moving around it. We still don't know what dark matter is made of, but scientists have proposed several candidates, including weakly interacting massive particles, or WIMPs, and axions. The search for dark matter is one of the most exciting areas of research in astrophysics today. Section 7. Black holes, the universe's vacuum cleaners. Speaking of mysterious objects, let's move on to black holes. These are regions of space-time where gravity is so strong that nothing, not even light, can escape. Imagine a giant cosmic drain, sucking in everything that gets too close. Black holes are formed when massive stars collapse at the end of their lives. The core of the star collapses under its own gravity, creating a singularity, a point of infinite density and zero volume. Black holes are invisible to telescopes, but we can detect them by observing their effects on nearby matter. As matter falls into a black hole, it forms a swirling disk of superheated gas called an accretion disk. This disk emits intense radiation that we can detect from Earth. Section 8. Cosmic microwave background. Echoes of the Big Bang. Remember the Big Bang? Well, it turns out that the Big Bang wasn't exactly a silent affair. It left behind a faint afterglow of radiation that permeates the entire universe. This radiation, called the cosmic microwave background, is like a cosmic fossil, providing us with a glimpse of the universe as it was just 380,000 years after the Big Bang. The cosmic microwave background is remarkably uniform, with almost the same temperature in all directions. But there are tiny fluctuations in the temperature, representing the seeds of the large-scale structures we see in the universe today, like galaxies and galaxy clusters. Section 9. The future of the observable universe. What happens next? So, what's next for the observable universe? Well, the short answer is, we're not entirely sure. The universe is a constantly evolving place, and predicting the future is a bit like trying to predict the weather a million years from now. But, based on our current understanding of physics, we can make some educated guesses. The universe will continue to expand, and the expansion will continue to accelerate due to dark energy. Galaxies will move farther apart, and eventually the night sky will become dark and empty as the light from distant galaxies will no longer be able to reach us. But even though the universe may seem like a lonely place in the distant future, there will still be plenty of activity on smaller scales. Stars will continue to be born, live out their lives and die, some in spectacular supernova explosions. Section 10. The Universe of Unknowns. Keep exploring. The observable universe is a vast and mysterious place. full of wonders and puzzles that continue to challenge our understanding of the cosmos. From the mind-boggling distances and the bizarre properties of dark matter and black holes, to the echoes of the Big Bang and the uncertain future of the universe, there is still so much we don't know. But that's what makes exploring the universe so exciting. Every new discovery leads to more questions, pushing the boundaries of our knowledge and inspiring us to keep searching for answers.